Today we're going to talk about synthesis and decomposition reactions, both types of reactions that are important in the world of chemistry. So let's go ahead and start with a synthesis reaction. Synthesis reactions are going to take a general form, and the general form is going to be a single atom or compound reacting with a single atom or compound to produce a single atom or compound. Essentially, one element or compound reacting with one element or compound produces another element. They just kind of synthesize or come together all as one. Now here's a good example of a synthesis reaction. It was what we saw yesterday in our lab. And yesterday in our lab we took some magnesium in a solid form and we placed it into the Bunsen burner and we got it burning. Once it started burning, it burned with oxygen gas coming from our atmosphere. So essentially we have a single element, magnesium, burning with a single compound. And what we did is we created a new compound. And the new compound we created was magnesium oxide. Now when we put these two together, we're forming an ionic compound. So we have to go back and look our charges up. And remember, you'll need a periodic table to do this. And so we need to look up the charge of magnesium. Magnesium is in column 2A. And so everybody in column 2A, if we remember, forms a 2+ charge. Then we look at oxygen. Oxygen is in column 6A. Everybody in column 6A forms a 2- charge. And then what we do is if we remember, we crisscross those charges. Bring our 2 down, bring our 2 down. Now we have 2 and 2, which we can reduce down to 1 and 1. So essentially our compound formed is MgO, and that was in the solid form. That was our white powder that was left over at the end. I'm going to go ahead and erase off this. Now what we just need to do is we need to balance our equation. Okay, so let's balance this equation. So on our reactant sides, we'll write down the number of magnesium and the number of oxygens. And our product side, we're going to write down the number of magnesium and the number of oxygens. So we'll start off with magnesium here. Magnesium, we just have 1 here. And on the product side, we have 1. So magnesium is currently balanced. On the reactant side, we have 2 oxygens. But on the product side, we only have 1 oxygen. So let's go ahead and place a 2 in front here. And then let's total everybody up. So now we have 2 magnesiums, we have 2 oxygens. And then on the product side, we have 2 oxygens, but we only have 1 magnesium. So we're going to go ahead and place a 2 here. And now we're all balanced out with coefficients of 2, 1, 2. And again, we have a single magnesium reacting with a single molecule of oxygen to form a single formula unit of magnesium oxide, which would be our synthesis reaction, putting something together to form a new compound. Now, decomposition reactions are pretty much the opposite of a synthesis reaction, and we did see one of these yesterday in our lab as well. Decomposition reactions usually take the form of a compound that gets broken up into its elements, or elements that make up another compound. So essentially we have a single compound being broken down into single elements or compounds. And so the example that we saw yesterday in class, or in our lab, excuse me, was we took some 3% hydrogen peroxide solution and we decomposed this with a catalyst, manganese dioxide, and we saw, oops, sorry about that, we saw a bunch of bubbles formed, and those bubbles were oxygen gas. What was left over at the end was also some water after the oxygen gas, and we tested for the presence of that oxygen gas. So this would take the form of a decomposition reaction with a single compound breaking up into a single compound and another compound. Let's go ahead and balance this guy out real quickly and make sure we're all set up here. Okay, so we have hydrogens, and we have oxygens, and then we're going to have hydrogens, and then we're going to have oxygens on this side. So we'll start with the hydrogen. We have 2 hydrogens on our reactant side, and we have 2 hydrogens on our product side. They are currently balanced. We then have 2 oxygens. We have 2 oxygens there, plus another additional oxygen there. So we actually have 3 oxygens on our product side. So what we're going to do is anytime I see an odd number, I'm going to go ahead and make it even. And so I'm going to place a 2 in front of here. Now we have 2 times 2 for hydrogens, which gives me 4 hydrogens. I have 2 oxygens there, plus I have 2 more oxygens there, so now I have 4 oxygens. And so let's double check on the other side. I have 2 hydrogens, so let's go ahead and place a 2 in front. That gives me 4 hydrogens, and then we have 2 times 2 for 4 oxygens, and so now we're balanced. So again, decomposition is breaking up a compound. Synthesis is putting a compound together.